Hey guys, this is Zap. I'm uploading this video after uploading the assignment for this week. And the assignment for this week involves building one of these Excel models that we've been working with in class. Now, a lot of the stuff that in this video we're going to show in class, but I know that not all of you are familiar with Excel or familiar with constructing these types of models. So if you're struggling with that, hopefully this video should help you out. Okay. So let's just recap real quick what we've been doing. Okay, so the assignment for this week gives you a production function for a hypothetical firm. It gives you some assumptions about that firm, and then asks you to find the scale of maximum profit and set up the model in Excel, just like we've done in class, to find that scale of maximum profit. Okay, and so in order to do that, okay, we first need to set up our Excel sheet. Okay, so let's have a look at our Excel sheet over here. So the way I've set up this sheet, okay, so by the way, if you don't have a copy of Excel, you can do this in the computer labs. Okay, I'm working from my home computer. Now, in this first sheet in Excel, okay, going across up here, I have the various different things we need in our model: the level of output, the labor needed to achieve that level of output, revenue, cost, and profit. Okay, then I've left a spacer column here. Column F is a spacer column. You go, how did I make that small? Well, you can resize a column just by dragging up here, okay, dragging between the letters. And then over here, next to the spacer column, I have my parameters. Okay, now these parameters, they match what was in the assignment sheet. Okay, so you see in the assignment sheet, the level of technology is 10, available capital 1, and then wages and price of output, $10 and $15 respectively. Okay, that's what I have coded in over here. I've just typed them in, and I've typed in the appropriate values. Okay, so what is this supposed to look like in the end? Well, let me show you what it'll look like in the end. Okay, so here's what it should look like in the end. We have output going down over here, starting from 1, and then going all the way down to 200 units. We're going to go to 200 units in this model. Okay, and what we see calculated for each of those output levels is the amount of labor required, the total revenue, the total cost, and the amount of profit in dollars. Okay, and so you can see, okay, so here as we increase output, profit is going up and up and up. I've also included 3 graphs, and this is part of the assignment, creating these graphs. I've created a graph for the amount of labor needed, the amount of total revenue and total cost, and the profit. Each of these simply graphs what is contained in the columns over here. And here you can see, once I have that graph, it's very easy to identify the scale of maximum profit here at 150 units. Okay, so this video is going to show you how to make this model. All right, well, the first step, okay, is to make our outputs. Okay, so, well, actually, the first step is to set things up like I've done here. Once you've done that, okay, first thing we need to do is we need to create output levels from 1 to 200. So the way we do that is pretty simple. We just put in 1, 2, 3, okay, put in a few numbers, and Excel is smart enough to know that, okay, it can recognize this pattern. So once you fill that a little bit, just go ahead and select those 3 cells. So click and then drag to select. Okay, and then what you're going to do is you're going to move your cursor down here to this tiny little box. You guys see this little box in the corner. When you mouse over it, your cursor will change to a black plus sign. Okay, and now you can simply drag that downward. And you'll notice as you drag that downward, the computer automatically fills in the numbers. Okay, so we're just going to drag that. We're going to keep dragging that down. We're going to drag that down and down and down, all the way to the bottom. Okay, and we're going to stop at 200 units. Okay, so now you see we have the numbers 1 through 200 in this upper column, in this first column. Okay, so that's the amount of output. How do we compute how profitable the firm is going to be at each of these output levels? Well, profit is simply the difference between revenue and cost, right? So we need to know what the revenue and the cost are going to be for these various levels of output. Well, revenue is easier, so let's start with revenue. Okay, remember, for this model, we're assuming that the firm simply sells whatever it produces at the price of output, at the market price of the output, which for this situation is $15. So, okay, so in other words, this revenue should simply be equal to the level of output times the price of output. Okay. Well, okay, so what is that? What is that for? How do we do that? Okay, so I'm going to double click inside this revenue box. Okay, I'm going to press equals. And as soon as you press equals, Excel is going to know that you're about to enter in a formula. Okay, and once you're in this mode, you can actually directly click on a cell and tell it what you want to multiply. Okay, so in this case, what is the revenue equal to? It's equal to 1 unit of output times the price of the output, which is 15. Okay, so clearly, okay, our revenue is going to be 15. Okay, now I don't want to repeat that. I don't want to have to enter in that formula over and over and over. So what I can do is I can fill down. Okay, so how do I do that? I can drag like I just did, but you can also, oh, well, actually dragging is probably the best way. So let's drag this column down. So I'm going to take this, I'm going to drag it down, down, all the way to 200. Okay. Okay, and you'll notice that there's a bit of a problem here. Okay, why are the rest of these all 0? Well, let's double click in this cell and see what's going on. And you see what's going on is Excel has made a bit of a mistake, right? It's what we want it to do is multiply the two units output by the price of the output to get 30. But you see, it's shifted this green square over here down as well. It's continually shifting it down. Okay, see over here, it's shifting it down automatically. That's good. We want it to track the level of output. But over here, we don't want to keep moving that down. We want the price of the output to stay the same at 15. Okay, so how do we resolve this issue? Well, what we need to do is we need to fix our original formula up here. So this original formula, A2 times H5, okay, we want this H5 to remain constant. And the way you do that in Excel is you put in a dollar sign. So I'm going to put a dollar sign in front of the 5, and I'm going to put a dollar sign in front of the H. So now I have dollar sign H, dollar sign 5. I'm going to press Enter. Okay, and then to update the rest of these downwards, what I'm going to do is I'm going to select this first cell, and then there's no need to drag again. You simply need to double click this box. So if I double click this box, okay, notice, okay, now it's filling out everything correctly. Okay, so I have revenue here, right? This is A2 times 15. This next one is 2 times 15. This next one is 3 times 15, etc. Okay, and so here's our revenue function. And what we see is obviously the firm is making more and more revenue as it's creating more and more output. Okay. Okay, so that's the first computation. Okay, so the next thing that we need to do is figure out how much it's going to cost the firm to produce 1 or 2 or 3 units of the good. Now, how do we do that? Well, as you recall, for this simplified firm, we're assuming that the firm already has capital and already has the raw materials that it needs. The only thing that they have to buy, is labor. They have to hire labor hours in order to produce the good. Okay, and how much labor is necessary in order to create a given amount of output? Well, that's where we need the inverse production function, right? The production function, the regular production function, tells us how much output we get per unit of labor used. The inverse production function is going to tell us how much labor we need in order to create a certain amount of output. Okay, so now let me go over here to this this file. Okay, so in our problem, okay, the production function is given by Q of L is equal to A times the square root of K and L. Okay, so how do I solve for the inverse production function? You should have already done this in a previous part of the assignment. Okay, but if you have some trouble with it, okay, here's how you do it. So Q is equal to A square roots of KL. Okay, that's my starting function. Okay, and remember what I'm trying to do here is I'm trying to solve for L. I want L in terms of everything else. So the first step is to square both sides of the equation. Okay, so we have Q squared is equal to A squared times K and L. K and L are now out of the square root because we squared them. Okay, and then finally I just want to solve for L. So I want to divide both sides of this expression by A squared K. And so finally I end up with Q squared over A squared K is equal to L. Okay, and so here, I've just rewritten it a little bit to be a little bit nicer. Okay, so here, the amount of labor needed to create a certain quantity of output Q is simply equal to Q squared over A squared times K. Okay, so this is the formula that's going to tell us the amount of labor needed. We simply need to transfer it to Excel. Okay, so that's what I'm going to do. So I'm going to say labor needed is equal to the quantity of output squared divided by the amount of, what was it again? Divided by the technology squared. Okay, so here's our technology level. So again, I just want to click that, squared. Yeah. And then times the capital level. And the capital level isn't squared, it's just in there as a level. Okay, so it's Q squared over A squared times K. And then I want to actually put this whole bottom thing in parentheses. Okay. Okay, so you should get that in order to produce 1 unit of the output good, you only need basically 1/100th of a man-hour of labor. Okay, so you don't need that much labor to produce 1 unit at all. Okay, and let's update that downwards. So now I'm going to take that, I'm going to double-click this little square thing, double-click. Okay, oh, wait a second, we got this problem again. These things over here need to be absolute cell references. They need to not change when we update downwards. Okay, so I'm going to put a $sign in front of the green. I'm going to put a $sign in front of this purple cell as well. And I'm going to press enter. Now this is always going to refer to these two values over here. Okay, it won't incorrectly shift downwards like it's doing before. Okay, now if I update that all the way down, okay, that's the amount of labor needed. Okay, so we see that obviously as you make more output, you need more and more labor. Okay. So finally, okay, let's compute now the cost. Okay, so how much is it going to cost us to produce 1 unit of output? Well, that's just equal to the amount of labor that we need. Remember, labor is the only thing we have to pay for in this model, times my wage level. Okay, times the wage. And again, here I'm going to put in those $signs to hold that cell constant. And I'm going to update that downwards. Okay, and so here's our cost. And then finally, profit is just the difference between revenue and cost. So profit is going to be given by revenue of 15 minus the cost of 10 cents. Okay? And finally, we're going to update that downwards as well. And now, we basically have our model. Okay? Now, note that our profit, okay, starts small, initially increases, okay, reaches a maximum value somewhere around this region, okay, somewhere around 75 units of output. We reach the maximum profit of something like $560. And then if I continue to make more and more units, my profit actually starts going down, okay? And in fact, at some point, it even becomes negative. I start losing money, right? Now, why is this happening? It's because our cost eventually outstrips our revenue. Okay, and in order to see that, we're going to insert some graphs. Okay, so how do I graph some of these things? Well, the first thing that I'm going to graph is the labor needed as a function of the output. So how do I do that? Well, I select my first column, output, and then I'm going to hold down Command on a Mac. On a PC, you want to hold down Control. Okay, so Command on a Mac, Control on a PC. And that's going to let me select this other column. So I'm going to select column A, and then I'm going to hold down Command, I'm going to select column B. And then I'm going to go up here to Charts. Okay, go up here to Charts. I'm going to select Scatter, and I'm going to select this first option, the Mark Scatter block. Okay, and there we are. There's the amount of labor needed. And you can see this nice convex shape to the amount of labor needed. As you produce more and more output, you actually need more and more labor. Okay, this is reflecting the law of diminishing returns. Yeah. So that's labor needed. Okay, now how do I make the other graphs? Well, we're going to put cost and revenue in the same graph. Okay, so let me do that. So I'm going to select, once again, I'm going to select output. I'm going to hold down Command, select revenue, and I'm going to select cost. Okay, do that just by clicking on these headings here, clicking on the letters corresponding to the columns. Okay, and I'm going to go to Scatter, insert a Mark Scatter. Okay, here we are. There's revenue and cost, each as a function of output. Okay, and then finally, I'm going to select output, hold down Command, I'm going to select profit, scatter, Mark Scatter. Okay, and there's our profit. Yep. Okay, and here you can see that peak. Here's that peak at 75 units. Okay, so now the nice thing about setting up these things in Excel, okay, is that we can really quickly change the assumptions of our model and immediately see what the effects what the effects are. Okay, so for example, here, let me move things around so you can see everything at once. Okay, so for example, suppose I ask the question, okay, what's going to happen to our firm? How is the scale of maximum profit going to change if we increase the capital level of the firm? Say we increase the capital level from 1 to 1.5. Okay, well, I can do that, right? I can just literally go into this cell and change this 1 to a 1.5. Okay, and if I do that, all of the numbers that we've computed are going to update themselves. Okay, and so you can see here that when we increase the capital level by 150%, the scale of maximum profit, according to this graph, shifts outwards, right? Before it was 75, now it's some higher value, maybe closer to 110. Okay, now let's set that back to 1. Okay, we can ask ourselves, well, what happens if we increase the wage? Okay, how does that change the scale of maximum profit? Say we make the wage $12 an hour instead of $10 an hour. Okay, well, you'll notice that the scale of maximum profit shifts backwards a little. Okay, it becomes now a little bit less than 75. If we increase the wage a lot, okay, you'll see that even more noticeably now, okay, the scale of maximum profit has become less than 50. Okay, and you can read it in the graph, and you can see that reflected. You can see that reflected in this column of profits as well. Obviously, the graph is just displaying the numbers in the column. Okay, so you can see the profit, it goes up, it goes up, it goes up. Okay, but around 250 units, or rather around something like 280 units, okay, the profit starts going down again. So it goes up to around 280 something, and then it starts going down again. Okay. All right, so the rest of the problem set, okay, is going to ask you to see what happens to the firm, see what happens to the scale of maximum profit when we alter things like the technology level and the wage. And you can do that just by updating these parameters once you've created this Excel model. Okay, so so that should help you guys complete the homework. If you have any questions, please ask me in class or come to office hours or put a post right here on Piazza. All right, have a good one.